about it. So these can prove a little bit more challenging on the mixture problems. So go ahead, take a look at number 1 together on the mixture problems. And a mixture problem, maybe we should discuss like a couple ideas of a mixture problem. In a mixture problem, you would have things like in chemistry, like chemistry, let's say, is one. I do basic mixture problems when I'm looking to make a weed killer spray. Okay, so you can do Roundup is one option, but maybe Roundup isn't great for the dog. I don't have a dog, or great for kids, right? It's like if you look at the back of the Roundup bottle, it's like do not touch, do not spray in your eyes, you will die. Make sure no animal or child goes near this spray for 3 days, and there's kind of. So maybe you don't use Roundup to kill things, so you would use maybe vinegar. Okay. And you might think, okay, I don't know much about vinegar. Well, let me tell you, household vinegar is actually only a 5% concentrate. So the general white vinegar, distilled vinegar, you guys ever have vinegar at home? And you use it for baking and cooking. We use it a lot for making buttermilk, for making our scones. You can use vinegar and milk and it turns it into buttermilk, sours it a little bit. So vinegar, though, is 5% concentrate. That's usually not enough to kill a plant because you can actually kill things with vinegar. It'll kill bacteria, different types of bacteria. You can use it as a cleaner and it's not as harsh as other cleaners because it's edible. Vinegar is edible. Not that many people drink straight vinegar. Anybody? Oh, you do.
Salt kills plants too.
Yeah, so a vinegar, salt, and then you use soap, Dawn dish soap as a solution in there as well, and then the soap helps retain it on the plant leaves. And it's kind of a natural way to go. But 5% is enough. So when you look at your bottle of vinegar, you don't need to write this down, but you have this bottle of vinegar. In that, the whole thing is full, right? It's 1 gallon, but in that, is it actually a gallon of vinegar? No, it's not actually a gallon of vinegar. It's 5% vinegar and then 95% water. So that's all it is. So what you can do, though, is you can buy concentrated solutions of vinegar that are actually, like I'll buy a 40% vinegar and then it's a 60% water, like that. And now it's not actually separated out like that right in the bottle. It's all mixed together. But that's just to visually see. So when I take a 40% vinegar, it'll actually eat through concrete. So if you spill some on concrete, it'll eat through it if it's the full concentration and it sits there. You have to be very careful. You have to be careful. You don't want anybody drinking that. That you don't use for cooking because it's very high concentrated vinegar. It's not good for you. So, but I'll take that 40% and what I'll do is I'll dilute it and I'll make my own bottle, my own little spray bottle. And in that, I actually don't want a 40% concentrate because that's excessive. I don't need that. And so what I need is like a 20% concentrate. So what I'll do is if I want a 20% concentrate of vinegar, I'll take my spray bottle and I'll pour half of it full of the 40% concentrate and then half of it full of water. So I get water and then I get vinegar. So if I do half of it was going in as a 40% concentrate, but then I poured half with water, what does it turn 40% into? If I'm only doing half of it, it turns it into 20%. Yeah, so then I get a 20% concentrate. That's an easy math one, it's just half. So if I wanted to mess around with the mixtures, I could. You can actually buy like 70% concentrate vinegar. I haven't bought that. That'd be pretty powerful. So I don't know. I haven't looked. I haven't Googled if you can buy 100% vinegar, but you probably can somewhere. It would be. But you open the bottle on that vinegar and it just hits you. Your eyes burn just slightly. You're like, okay. So I usually wear goggles and gloves and But I think it's an upgrade from Roundup. Is my thought. And my weeds. Okay, so that's the idea of the concentrate. Also, when you guys go to buy juice or something, you're like, oh, I really like some sort of juice. A lot of times what you're buying in your juice bottle is not actually, and I maybe should have brought in something, it's not actually 100% OJ, orange juice. Now, sometimes it is, sometimes it isn't. Sometimes you're only buying, like if you go to buy a good one, a good example of this is, and you're going to drink this. Does anybody go to buy a juice to drink? Buy 100% lemon juice to drink. You know, usually you're not buying, what do they call it? They don't call it lemon juice when you're like, oh, I'd like to order at the restaurant. You're like, I'd like to order a lemonade. Yeah, you're not ordering lemon juice. Lemon juice would typically be 100% lemon juice. You're usually, when you're going to buy some sort of lemonade, right, it's maybe 3% lemon and then 97% other stuff.
Sugar.
So yeah, mostly sugar and water, right? And they might add, strawberry lemonade. And they'll, tack on 3% lemon, 3% strawberry, and then a whole lot of sugar and a whole lot of water. Right, so those are those concentrates. Now, if you add more lemonade, then these concentrates go down and things like that. You do this with mixtures for, does anybody like peanuts and cashews and, okay, if you ever like are at the store and you're buying mixed nuts, okay, you buy a container of mixed nuts. Some people like to buy that. Typically in mixed nuts, anybody know like the cheapest edible nut that you buy like at the store? Not almonds.
Walnuts?
Not walnuts.
Cashews?
Peanuts, yeah, peanuts are the cheapest, usually the most inexpensive nut. So when you go to buy a mixed nut container, right, what you really don't want is a ton of peanuts. Because you're like, those are the cheapest. I really like cashews, pecans, toasted pecans with some butter and salt. M&Ms are typically not in the mixed nut category. That's a trail mix. That's a trail mix. So right, or right, aren't you disappointed when you go to buy trail mix and it's mostly raisins?
Yes.
No.
So, but in a mixed nut container, typically what they'll advertise, anybody like macadamia nuts? I mean, this doesn't speak to everybody, but macadamia nuts are very expensive. Okay, so when you go to buy the mixed nuts and they have macadamia nuts, is it going to be 50% macadamia nut? Usually not, because if you put in 50% of the most expensive nut, what's the price on this type of container, high or low? High, right? So they don't want to say, here's our mixed nut mixture, and it's going to be $30, and you're like, man, that's expensive. Usually you're looking for something that's a better value. So you go to Costco, and you're looking at this mixed nut, mixture, and it's whatever it is. It's like $14.99 for a container. Well, if they made it mostly macadamia nut, they're going to have to sell it for, I'm making up a number, like $30. And when the consumer goes to buy, are they going to gravitate towards the $30 or towards the $14.99? $14.99, especially when they see mixed nut container, they're like, well, if it's all macadamia nut, fine. We're willing to pay a nice price for that because those are expensive. But if it's a mixed nut mixture, they're not willing to pay this, they're willing to pay this. So what they got to do is figure out the mixture that's going to be cost effective for them so they can make money and then the consumer will buy. The issue is if I go to buy the $14.99 and I'm looking at it and I'm like, wait a second, 50% of it is peanuts, the least desirable, edible nut, if you will. It's like, and I'm paying $14.99, not into it. So usually, a lot of times they'll advertise something like this. They'll say less than, whatever they want to advertise that is 30% peanuts. Right? So then when you go to buy it, you're like, oh nice, it's not made up of a ton of peanuts. Usually where I get into this, although they never advertise it as this, but breakfast burritos. And you gotta buy a breakfast burrito. And who likes breakfast burritos? Oh man. I've got my places, I could give you my list of favorite breakfast burritos in Missoula.
Do you have a list of all of them?
Well, mental list.
Number one.
Number one, it's a close toss up. But it would probably have to be, when it's done right, sometimes they're off, but mark it on front with the chipotle aioli sauce. It's good. But sometimes the issue is the potatoes are undercooked and they're crunchy, like you're like biting an apple. And you're like, Double K Ranch, they put their pork fat French fries in the breakfast burrito, and so they're nice and crispy. Top tier. So the issue with this is here you have your breakfast burrito, right? You're really excited, it's all wrapped up, and you're like, okay, oh, I'm so hungry. And then you unwrap it and you start chomping in, and you're like, what am I eating? And you realize you're eating 85%. What's like the least desirable part of the breakfast burrito?
What were you on?
It's a tortilla! So right, everybody's got a different opinion. The thing is, actually we could go with this, what's the least expensive part of the breakfast burrito? Yeah, the potato.
Potatoes the best part. Yeah, the potatoes the best part.
So when you go and you're paying when I'm paying $12 or whatever it is for this breakfast burrito, and I'm getting 85% potato in there, and I'm just like gnawing on a baked potato, I'm like, I could have just bought a potato for 5 cents, cooked it, and then gnawed on it. Like that is so discouraging.
Wrapped in tortilla.
So when I get the premium breakfast burrito, there's just a slight amount of, maybe it's 10% potato, and then what's optimum is 50% bacon.
Yes.
Right?
Yeah.
And then maybe you have like so then you have 40% other, which is your eggs and maybe your onion and whatever else it is. So you have now they don't ever advertise it as 50% bacon or whatever it is, but you'll know they love filling it with potato. Why? It's cheap, and it makes the burrito look big, but it's cheap. So that's why they love filling that. So when I pay $12 and it's mostly potato, I'm like, that I'll never go there again. Now if it was $2, fine. So these mixture type problems right? Anybody go to Papa Murphy's? Yeah, and you ever watch them make the pizza? What are they, most of the time that I've been in there, what are they doing as they make your pizza? They're taking each ingredient, what do they do with it? They weigh it.
Oh.
Did you know this? Have you watched them?
No.
They weigh it and then they sprinkle it, right? Because they want to optimize their profit, which is fine. That's fine for them to do, optimize their profit. But they'll count the pepperonis. Did you know that? They count them as a thing. Yeah, so they have this whole mixture to maximize their profit, yet still give you something that you desire. So that is what they do, whether you know it or not, that's what they're doing in most restaurants. That's like a breakfast burrito. They know if I use this much bacon, it's going to cost this much, right? So they're not going to overload it for you, unless it's accidental. Okay, so mixture problems. Okay, let's talk about number one. Now, if you have a calculator, get a calculator out. What?
Nothing.
Okay, just you randomly spouting off as you go. Okay. So let's go with number one. So yeah, that's the general idea with mixture problems. By the way, we're doing 2 days of this, right? So it's not due tomorrow. This will be due whatever. Tuesday. Is today Tuesday? It's supposed to be due on Thursday, and then we're gonna review on Thursday and then test on Friday. Oh,
We're all
my.
cooked.
Oh,
It's so hard.
We have a science test on Friday, Mr. Elson.
yeah, get over it. Here we go.
That's
Oh.
Number 2.
right. That's right.
What's the phrase? Cry me a river, build me a bridge, and get over it.
Oh.
Is that good?
Friday.
Yes, it is.
No, it's on Monday.
And you have
That's
several
not
days to
better.
prepare.
Yeah.
Yeah. Or another one is, Chris, you want some crackers and cheese without wine?
Yes, please. I'll take some crackers and cheese with my wine.
So, here we go, number 2. Alright, number one. Amount mixture. So they have the chart there, and then the percent salt, and then the amount of salt. So whatever this is, right, it's some sort of mixture, and they say the total amount is 15 grams for this whole thing, the whole weight is, right? And then, 4.95 grams of it is your salt. The question is, what is your percent of salt on that? So how would I figure out what my percent of salt is? So this is actually kind of a percent problem as well. You would take your total weight, which is 15 grams, multiplied by, if you will, P, or you can pick any variable you want, S for salt, except S might stand for the weight of the salt, so let's go with P as the percent of salt. And so then that would equal, you already know what it equals, 4.95. And so that would be a little equation you could set up. You take your calculator, it would be beneficial. Again, I'll have a problem on the test. These mixture problems, I'll make it so that they're solvable, or you only have a couple long problems to do with longhand multiplication or division. So you take 4.95, and then you divide by 15, and Jed's got it for us. What do you get for the percent salt?
33%.
33% exact, or is that rounded? Exact, 33% exact, okay? So you get 33% for that. Now you actually you didn't get out 33% on your calculator. What did you get?
0.33.
Yeah, 0.33. Don't forget, turn it into a percent because it says percent salt on that for number 1. So then you'll put that in. Okay, now number 2 says, we're going to fill in the chart, the amount of mixture is x plus 80, and then the percent of ingredients is 25%, and then they want the amount of ingredient, and I think I made an error there. Let me see on yours. I think the error is that the whole chart's filled out for you. I think what I was supposed to have blank there is the amount of ingredient. So what was blank? What was supposed to be blank? You're supposed to take your amount of ingredients, multiply it by your percent of ingredients. So multiply by 25%, and then that would be equal to the amount of ingredient, which is already filled out in the chart. So I answered that one for you accidentally. And you can see there it's 0.025. Typically, you take the number that you're going to distribute in and put that out front. So it's already put in there for you. There's nothing to solve. You can't solve because it's an unknown. We don't have an equation to set up. So the answer was actually supposed to be that we were supposed to do, but it's already done for you. Okay, so moving on to number 3. Utter Brilliance is a mixing cream that is 30% butterfat with milk that is 3% butterfat to make 45 gallons of cream that is 12% butterfat. Anybody drink heavy whipping cream?
I don't just
Green?
drink it.
Yeah, you should. It's amazing. So the best heavy whipping cream, actually, I think the Kalispell Creamery is the best, at least mass-produced. Probably not. I mean, the best would come from the cow. But the best mass-produced is Kalispell Creamery, and they don't have any additives in it. Once you get into the additives, the ones which is most everything else that you would buy, you can, the Dairy Gold heavy whipping cream, 40% fat.
Oh.
That is awesome. So you think about 40% fat versus whole milk. Anybody know what whole milk fat percentage is?
No.
4%. So you're getting 4% for your whole milk. Compare that to heavy whipping cream is 40% fat. So good. And then you go 2% milk fat, 1%, and then you have. I'm so sorry if your parents made you drink skim milk. It's so bad. Okay, so no offense to the skim milk drinkers out there. All right, so let's take a look at this. We have this brilliance, utter brilliance. Okay, so what we need to do is fill in this chart. All right, so there's some blank, now in this case these are all blank, but let's look at this. It says, utter brilliance is a mixing cream that is 30% butter fat with milk. That is 3% butter fat to make 45 gallons of cream. That is 12% butter fat. So if we look at the left side of the chart, we can see there you have cream, then you have a blank, and then you have a mix. Meaning they're taking cream, right, and then they're mixing it, right? It is 30% butter fat with, what's the missing portion in there? What are they mixing it with? There, it's not a numerical value. We have the cream, right? And then we have a blank there, and then you have the mixture, right? So what should go in? What are they mixing with the cream, if you will, to create the mixture? Milk, right? So then we say, okay, they're putting milk in there. All right. So again, you guys have this chart in front of you. I made your life a little bit easier there. Okay, so then the next thing is the gallons of solution. So the gallons of whatever the solution is. So if you think about, do they tell you for that first one, the gallons of cream used? I don't think they do they?
Yeah.
They say 30% butter fat with milk. Okay, that is 3% butter fat to make 45 gallons of cream. So you know the total mixture is going to be what? The total mix. What's the gallons? The total mixture is 45. So you have some amount of cream mixed with some amount of milk to make 45% mixture. So we could say, you could say something like this, C for cream. I think they might use B. Where would the B come from? B would stand for the butter, what is it? The butter fat. So that would be like the butter fat. Now, we don't want to put M for milk because now we've made how many variables? Two. If we can avoid two variables, we like to avoid two variables. Is there a way to represent the amount of milk in terms of B? It's kind of like stating in the rate times times problems, like this person ran for T amount of time, the other person ran for 1 hour less. And you would say, oh, it would be T minus 1 or T plus 1 or something like that. So is there a way to represent the milk in terms of B and also our 45? Yeah, Tia.
45 minus B.
Yeah, let's check it out. 45 minus B, I'm liking that. Okay, a lot of these problems will be set up the same way, or similar types of things, right? So if you have a total of 45, it's made up of milk and cream. So if 10 is the butter fat, then 35 is the milk. If 20 is the butter fat, then 25 is the milk. And so you just take your total minus the butter fat in this case. Okay, the next thing is the percent of butter fat, right? Percent of butter fat. All right. Now, in this case, what's the percent of butter fat in the original? It says cream that is 30% butter fat. So they tell you right there, what's the percentage of butter fat? 30%. Now, typically we'll write it as 0.3. If you have 30% on the test, I'm going to mark you wrong. But when we go to do our math or algebra, we're going to turn it into a decimal. So I like to turn it into a decimal there. Now, when we think about the milk, what is the percent of milk that's butter fat? Does it have some butter fat in the milk? Yeah, so it's not a complete skim milk, right? How much butter fat is in there? 3%. 3%. So this would be 0.03. Nice. Then our mixture is going to end up with 12%, right? 12%. 0.12. Does anybody actually go shopping personally, like you're shopping for milk for your family ever, or anything like that? If you ever shop for milk or for things like that, you'll notice that at the store, is whole milk more expensive or less expensive than skim milk? More expensive. Because whole milk has what in it? Fat. So if it's skim milk, what they've done is they've skimmed off the fat, and then they take the fat and they use it to make other things, right? So it can get diversified into other products and sold for more, right? But then if they're using whole milk, then they're having to use the fat in that whole milk, so it's more expensive. After whole milk, what do people like to put in their coffee? Half and half cream, right? Usually it's half and half, which is like twice as much as milk, if not more, because they're using a lot more fat. And then after half and half comes, what I love is heavy whipping cream. And then the heavy whipping cream is the most expensive because that's all of the fat that they can't use for other products. So what they're creating is a 12% mixture here, So again, I like 40% mixture. So in that, so then what do we have? The next thing is this. What is okay, so we have 12% mixture. Now, the gallons of butter fat is simply doing this. So you have the total gallons of cream times the percentage of butter fat equals I think that last one states what? It's the gallons of butterfat. Gallons of butterfat. Okay, so how much butterfat is in the cream? You would simply take your 30% times your butterfat, and that would tell you how much butterfat is in there. This is the gallons of butterfat, right? So you would do 0.3 times B, 0.03 times 45 minus B, and then 0.12 times 45. Now, if you want to go 0.12 times 45 and give yourself a value in there, that's fine too. What does that give us? 0.12 times 45. What do we remember that? 5.4. So you can also put in there 5.4 for that. Okay. So in this case, all we were doing was setting up the chart. We actually weren't going to solve any of it from that. Okay. So we want to do one more. Let's do number 4. I'd like to do number 4. If you go to number 4 now, it says make a table and answer each question. Okay, so on this, number 4, if 3 gallons of 10% salt water are boiled, when you go to boil salt water, what boils off?
Water.
The water. What's left?
The salt.
The salt. Yeah. So you go to boil, right? Anybody have a tea kettle at home? Anybody after you've used the tea kettle, do you guys wash your tea kettle every single time? No. So does anybody after you like a boiling or a hot water pot, you know, a hot water pot? So if you take a hot water pot and you have, you know, and you hit the button and it heats up the water, you have something like this?
Yeah.
Maybe, you know, turn it down and it heats up the water. And then after you've used it a bunch, does anybody pull it out and look on the inside? And if you look on the inside, what is there a lot of times? White crusty stuff. Yeah, and you're like, what's the white crusty stuff I've been drinking? What is the white crusty stuff?
Salt.
It's minerals, yeah. It's going to be minerals in there, so calcium buildups and things like that. So it's not actually bad for you, but it can clog things, right? So you have these calcium buildups. You'll notice there's no calcium buildups in here. How do you get rid of calcium buildups? Wash it. Yeah, sometimes washing it doesn't take it out because it's like solidified onto this. What breaks down calcium and the mineral buildups? Pro tip for you: you can help your parents clean. I told you about it at the beginning of class. Put what in there? Vinegar. Yeah.
Vinegar fixes everything.
Yeah, put vinegar in there, come back an hour later and you look and it's like, wow, it's all dissolved.
What?
And then make sure to leave the vinegar in there so when your parents hit the hot water and then they heat it up and they go make their tea.
Oh.
It's like vinegar tea. Okay, make sure to rinse it out. Yeah, so what boils off is the water is boiling, right? And you pour the water out, it actually leaves the minerals in there. So when you boil water, you'll leave the minerals. So you'll leave the salt in there. Okay, so we're going to make a table for this one. So we would say you have 3 things going on. You have salt water, and then you're going to boil the water away, and then you're going to be left with a mixture. So what I would put is you have salt. I'm going to put this over here. You have salt water. Salt H2O. You have H2O boiled away. That's what's happening, right? We didn't read the whole problem, but you got it in front of you. And then you have the mixture that's left. Something like that. Okay? So in this, then, we would say the original, kind of like we had over here, is your gallons of solution. So our gallons, what's our gallons of solution for the salt water, the initial salt water? What's your gallons of solution for that? They tell you right there, if 3 gallons, okay? So 3 gallons is your initial, okay? And then how many gallons are boiled away when you read the problem?
1.
1. Now I see the number 2 there, but it says what? it's boiled until there are 2 gallons left, right? So you boil the gallon away. How much mixture is left? How much of the salt water mixture is left? 2, right? So you started with 3, you boiled 1 away, you're left with 2. Now the question is, what is the percent of salt in the remaining 2 gallons? Okay, so that would be like our next thing is the percent of salt. Okay, so tack that far down to the chart. The percent of salt. The nice thing is, for the first one, they tell you what's the percent of salt in the first 3 gallons. 10%, right? So 0.1, if you want to write 10%, that's great, right? Now, when the water is boiled away, how much salt is in the boiled away part? We just kind of talked about it. How much salt is in the water that boils away? The steam that's rising. 0, right? There's 0, so it's okay to have 0. There's 0 salt that's boiled away. Now, the percentage that's left. So if you started with, remember, like a little picture, right? You know you have 10% salt at the bottom of this thing, and this whole thing is filled with water right up to there, right? So 10% of this whole thing is salt, but if you get rid of this much water, right? You get rid of it, it's gone. You still have the same amount of salt, but the percentage does what? Goes up, right? The percentage is going to go up. Same amount of salt, but the percentage goes up. But do you know what the percent is yet? You would say no. So you could put S for salt. I don't like S, because my S's look like 5s. I like P for percent. Sounds good. Okay, so then, what's our last part of the chart we might fill in there? If you know your gallons times your percentage of salt, times the percent of salt, that tells you the amount of salt, or gallons of salt. You could, whatever you want to say, it's amount of actual salt. So it's not the percentage of salt, it's your amount of salt. Sorry about the sloppy handwriting. Amount of salt. So now we say, okay, well, how much salt is in my original mixture? Not the percent, but the amount. So the amount is, what's 3 times 0.1? 0.3. So you have 0.3 gallons of salt, right? And the amount that's boiled away, what's 1 times 0? 0. And then here, it would just be 2 times P, right? And so it would be 2P for the amount of salt. What we know is now, if we've set up the table, okay, and then we're going to answer it, okay, so it says make a table and answer each question. Now we need to set up an equation. The equation is, we're going to state the amount of salt. So if I write 2P, that represents an amount of salt. An amount of salt has to equal what? An amount of salt. So I only have 2 options. I could either say it's equal to 0, which wouldn't make much sense, or it's equal to what? 0.3. So the amount of salt in my mixture is equal to the amount of salt that was in my original, because we know no salt left. And so now this tells me my percentage. So what is 0.3 divided by 2? 0.15, and then you turn that into percent. Jed's our master at turning things into percent, and you get out 15%. Would it make sense that our percent of salt went up? The amount stayed the same, but the percent in our solution went up. So we have less water, so the percentage is going up. Okay, great. Will we work on this tomorrow? Yeah. We'll do a couple more problems right away. We'll do those, kind of cruise through those next problems on the notes, and then give you time in class, hopefully, about a big chunk of time. Should you start on it tonight? Yeah, I would. These are tough ones. Well, they're just, a lot harder. I think they're harder than the break time problems. All right. See you guys. Have a great day. Good luck to the volleyball team. Is anybody in volleyball? Yeah. High school? You and who? You and Tia. And Tia. Okay. forgot about feeling. Very good.
Clearly.
Clearly.
Clearly.